We already know some of the... Alright, properties of the definite integral. So we already know a couple properties. Let me remind you of them. But it's consistent here with the definite integral. So when there's limits on the integral, that's all definite integral means. So if we didn't have any limits, we said that we could pull the c out and then evaluate the integral. And that's exactly what we can do here when we have limits on the integral. There we are. And then if we have two functions, if we had an indefinite integral, we've discussed that you can separate them. And that's the exact same thing that you can do here with the definite integral. So we integrate the first plus the integral of the second. And notice we're keeping the limits the same. Okay. So now I want to look at if you change the limits of integration. So let's say we do the integral from a to a of f of x dx. Let's draw a picture of that. Okay, so this is going from a to b, but if we're just going from a to a, it's just this line. And then the area of a line, so the two-dimensional area of a line is 0. So you're not integrating over anything. You wouldn't have any rectangles here. So that integral is just 0, which is fairly nice. And then let's look at if you change the limits of integration. So instead of going from a to b, now let's go from b to a. B to a of f of x dx. Now that's true, but all you got to do, since you're working backwards, is you got to put a negative sign. So if you change the limits of integration, you got to put a negative in front of them. Okay, last property, it's fairly nice. Let's draw a picture. So we're still going to go from a to b of f of x dx. And so we're imagining what we're doing here. So we're going from a to b. Here's our function f of x. And now what I want to do is look at if we have a c in the middle here. Now we could find that area of the first part and then add that to the area of the second part. Okay, and that's exactly what we're going to do. So now let's look at the limits here to finish our property. So the limit of the first area, the leftmost point is a, the rightmost point is c. We're still integrating over f of x dx. And then we're going to add that to the second area, the second portion here. The leftmost point in terms of x is c, the rightmost point is b. We're still integrating over our function dx. Alright, so using these 5 properties, we can simplify some of the antiderivatives that we have to use. And luckily, we get to use the fundamental theorem of calculus. So our problems should be a lot simpler to evaluate. Thanks for listening.